Okay, we're going to take a look at distance in midpoint here in this video. Now, the distance formula is really just a version of the Pythagorean theorem where the x2 minus x1 represents one side of a right triangle, while the y2 minus y1 represents the other leg of the right triangle, and our distance is really the length of the hypotenuse. But here's our formula up here in the corner, all set up for us, that we can just plug our numbers in. So we need to go ahead and plug in our x values. Remember, our points are always x followed by y, so we'll go our first x minus our other x, our first y minus our other y, subtract our x's, subtract our y's. Then all we have to do is work that out. We get a 25 plus a 100. Whoa, that went crazy. Then all we have to do is just add them together and we get 125. Then we need to remember about simplifying roots. We want to look for factors that are perfect squares. We do that. And we can say, oh, I know the square root of that 25. That's a 5. I'll put that in front. My other 5 that I have left inside stays there. So that's the distance formula. Just remember to simplify your roots and do not approximate unless it tells you to do so. Now, for midpoint, midpoint is really just the average. So we're going to be taking the average of the x's, average of the y's. So to do that, we'll take our first x plus our second x. Then we'll go ahead and move that out of the way, and we'll get 19 over 2, which you could, if you wanted, write it as 9.5 because it ends up being a nice, neat decimal. If it did not end up being a nice, neat decimal, then go ahead and leave it as a fraction. Now we got to go back and do the same thing for the y. So our first y plus our next y gives us 0. 0 over 2 is still 0. So we get either one of these two down here at the bottom as acceptable answers. Remember, it's a point, so write it as the coordinates of a point.